Okay, so here I will explain this code I have written for weblog parsing, or basically downloading the data from this given URL to answering the questions being asked. So to start with, first of all, I have imported the libraries like gzip, like for reading the compressed file that is in .gz format, and then I have like imported datetime, basically used to convert timestamp string into Python datetime objects, and and also pandas for used to structure and analyze data in different formats. So to start with, first of all, I have downloaded the file for which I have pasted this URL. And if we after analyzing the data, I came across different logs where I can see that we have different formats of, I can say, the http request, and I can find this three edge cases where the format of this given URL, http URL, is totally different from others. So because of that edge cases, I have coded the complete code in different format. So firstly, now to start with, like I have created an empty list to store each past log entries as a dictionary. So for that I have created an empty list. So to go ahead, with gzip.open, it basically opens the compressed log file in read text mode, and to start with, I have used for line in basically it will start a loop through each line in the file, which we have the rows. It will start from 1 and it will continue, and it will keep in looping. And then I have used strip line dot strip function, which basically is going to store the result in the line itself, which is doing removing white spaces on from the given format of the column and rows. So it will remove the white spaces and it will be stored in lines. And I have used then line dot split, which is going to store the values in parts. So what split is basically doing, like it breaks the line into individual space separated parts, like token, I can say. Like if, for example, if we have this particular values for different columns, then first it will collect locale. Then if we have spaces in between, so as it encounters with the first space, then it splits the complete text in different, I can say, different blocks. So locale will be a first column, and as it encounters the space, then we have this timestamps, then it will encounter with timestamp, then it will be a different column accordingly. So like this. Then I have used if length dot part is less than 2. So basically, if the length of any part is less than 2, so it will skip empty, or I can say we have a malformed lines, so it is going to skip if it is less than 2. If we have less than 2 tokens, then it will definitely skip it. And then we have different cases, like well formed cases. So basically, in well formed cases, what we have is we are checking if we have a double quotes uh, in the http request, and we have square brackets. So if we encounter this, then we will extract the host, their IP address or domain, which is basically the first token. So for that we have used taken 0, because it will be the first, it will be host as the first token. So we have given the indexing as 0. And for timestamp, basically, like we have used this to extract the timestamp string from between the brackets. Like if we encounter these brackets, so in between these brackets we will find the timestamp, and we will convert this in a date time format, like I can say um, the expected format for the date time. And let's then go ahead. So in this request, it extracts the http request from within the double quotes. Like we have this http request, so this will extract this particular portion which is inside the double quotes. So yes, uh, then it splits into parts, typically methods, file names, and protocols. Then moving ahead, we have if length request dot parts is less than 3. So if the request underscore part is less than 3, then it will rise an error, because to get a request, what condition we have added, like we need at least 3 components. If they are not, then we will get an error for that. Then we have file names. So like it takes everything between methods and protocol as the file name. For example, you can say yeah. So like it splits off query parameters to get path. So it is it will extract the file extensions like html or .pl or .gif from the path. So basically this is what it's trying to do. Then we have used try and expect block accept block. So it attempts to parse the http request code from the second last field. Basically this is the, I can say status. So it will extract this status code from this field. Like we have different columns, so from the last second field we will extract this. So if it fails, if it is there, then it will extract in this way. But if it fails, then we will get na, like if the value is missing. If we do not have any status, then it will give na. Then for bytes also, which is the last field, so we have used try and accept block. So what it is basically doing, it passes the number of bytes transferred from the last field. So all the bytes which has been transferred from the last field, it will transfer, counts the number of bytes. It treats, like I can say, this hyphen as 0, otherwise parses it as integer. If we encounters with this hyphen, then it will consider it as 0, or it will pass it as an integer. Or if the passing fails, it stores it as a missing value. So moving ahead, we have we now we will record we will append different fields to the record data table. So we have created a dictionary with all the extracted fields, and we will append them to the record table. So and if in case our any parsing fails, so we have an except block which will handle the exceptions. So if parsing fails at any point, then we will still record the host and the I can say field name, and mark all the other fields, like I can say field timestamp, status, bytes, as name, which is like not applicable. We do not have any values for these these particular fields. So it will give na, or like not applicable, or there is no time for a particular row, so it will give timestamp as missing. So yeah, and if there is no extension, then it will give none. Otherwise, is if we have malformed log entries, then also like we have handled them accordingly. So for that, if like handle it will handle lines that which we encounter through, like we do not have any quotes or brackets uh, there in host or timestamp or somewhere like that. Still it will try to extract the host and file name if there is no brackets and quotes available. Then also it will try to extract the file and host name, and it will marks all the other fields as missing, and all the it will try to attempt file extension if it is exist. If there is file extension, then it will definitely going to be stored here, and if do not, then it will give none. So now, after doing all these changes and checking all these conditions and all the edge cases which are possible, we have converted it to a data frame. So for that we have used pandas. So we have all the fields and every data in this records we have appended in records. So here we will convert it in pandas data frame. So for that we have firstly like checked for top 10 head values. So it will basically give us like starting 10 values for I can say the record table. So basically what it is doing, it converts the list of dictionaries, that is records, into a pandas data frame. So like which will be like we have done this because it will help us to like easily analyze and visualize of the past parts log data. So yes, coming to the questions we have. So first one, we have to like a count of total log records. So for that I have created a total records, and in that we have like length of data frame. So it will basically returns the total number of rows in the data frame we have. So I've stored it in total records, and then we have printed the total records. So you can see we have 7266739 records. So here each row corresponds to a single HTTP request, so it will consider all. So this will give us the total number of requests made to the server. So before we have different number of, I can say, the records, because it was excluding few of the edge cases. So after going through the data and looking at the data, I have came across the edge cases, and after that I have like considered the edge cases, and then we have got this total number of records as 726739. So next question is like we have to count unique host. So for that, like I've like from the data frame we have extracted the column host. For that we have used a data frame, then we have written the name of the column, that is host, and we have used n unique, a function which is basically used to count number of unique IP addresses or domain like hosts, I can say. So then we have printed the unique host, like as we have stored the value of the host column which consists of unique values, then we have stored it in a unique host. Then we have printed the value. So basically we are getting 2 as the unique value for the host name, that is basically I can say locale and remote. Locale is the one who are like the host or I can say the people who are logging from the particular university, and remote is from any external places. So yes, coming to the next question, that is date wise unique life file name counts. So for that we have we first need to filter like valid rows, so we will remove the entries which do not have any timestamps or file names. So for that we have stored the values, we have dropped the data from the data frame which do not have any timestamps or file names. So if they are na, that is null, then it will we will drop them. So and we also need to convert the date time in a correct format, that is date month and year format. So for that we have we have all the I can say we have converted the standard format time in a standard format time, that is this one, and then we have stored it in this particular format. Then we have grouped and count unique file names. So we will use group by for checking the, so basically group by it will group by date and count unique file names requested on that date. So accordingly we will get the unique file names that has been I can say requested on particular date. So we will get the unique name. Then it will return a dictionary, that is date in a date way. So next we have, so here you can see that we are getting an inappropriate format, the dates are in appropriate format. So that is date month and year. So coming to the next one, so we need to count the response 404 response code. So for that we have checked the status. If the status is equal to 404, then we will sum it up and we will store it in count underscore 4.404, and we have printed it. So in total we have 23,470 values which consist of status as 404. Then we need to fetch top 15 file names with the 404 error. So for that, firstly we will filter the rows which have 404 errors and have valid names. So for that we have checked the status. If the status is equals to is for that we to check whether the status value is equal to 404, we have used a double equal sign. And if the status is 404 and the file name, the column file name is not null, then we will store that particular values in df underscore 404 and then we will count the frequency of file names and get top 15. So to find the count the frequency of the file name, what we have done, uh, we have counted the values where head is 15 and data frame for these 404 file names, the file names for these particular, and then converted the list of file names and count in tuples. So yes, we have converted this in tuples. Then we have printed the file count. For that we have used we have created an iteration for file name count in qf underscore results, that is in a tuple format. Then it will count this and append the file name and the count. So what it is basically doing, like it filters rows where status is 404, where that is not found errors. Then it will count which file name result as 404 most often. Then it is basically returning the top 15 as a list of tuples. Then we have top 15 file extensions with 404 errors. So for that we have checked the status, and then extensions. We have we have created a list for that, and then we have stored them in a empty list. And similarly we have appended them, and we can get the extensions of those files whose status is 404. That is, we can say we have jpg, text, htm, etc. So yes, so coming to the next question, we have to like check for the total bandwidth per day in July 1995. So here is the output for that. And talking about the code, we need to filter out the rows where timestamps are not null and bytes are not null. So for that we will drop the values which consist of null values in timestamp and bytes column. So we will store it in valid underscore q7, and basically we need to filter it out for July 1995. So we have given the year as 1997, and for month as July is the 7th. So we have added a condition: if we have timestamps, year is 1995 and the date and the month is July, that is 7. So it will now we will convert the date in a correct format, that is we will use this standard format for time and date as well. So here we have converted in correct format. Then we will group by date and sum the bytes. So we have, for this particular July month of year 1995, we have grouped the data by date, and we have summed the bytes into a dictionary. Then we will get these columns, these values, like for 1st July we have data for the 1st July, that is we have timestamps and bytes. So for 1st July 1995 we have this number of bytes. Similarly for 2nd July we have this. So now let's come to the 8th question, that is hourly request distribution. So first of all we need to check for the condition, like we need to have a valid timestamp. So for that we will of course drop null values which we have in this particular column. So yes, then we have to extract the hours from 0 to 23 from the timestamp. So yes, we have copied it in this valid underscore q8. Then for calculating the hours, we have the timestamp. So with the help of timestamp we have calculated the hours, count the extracted the hours. So then we will count request per hours. So for that we have used the sort underscore index function, and we have counted the values for this, and we have stored it in q8 underscore request result. Then to show the result, we have started the loop. Like for hours, we will count it in q8. We have stored the result in q8 underscore result, so it will count the number of items here. Then it is going to print the hours here. So what it is basically doing, it is just extracting the hours from timestamp. Then it will count how many requests occurred in each hour of the day, then we have written it in a form of dictionary. So according to the this, we are getting these particular outputs. Then next question we have, like, we need to check for the top 10 most requested file names. So yes, for to check this, we have column file name. We have extracted the column file name, and we have count the values, and for checking the top 10, we will create a list of top 10 file names. Then we have again started a loop, and we have printed the file names and their count. So we have index.html as the first one, which is most requested file name. Then we have gif, 3.gif, 2.gif, similarly others. So what it is basically doing, like, we can filter out rows where the file names is missing, so that these will be removed, or we will ignore these cases which do not have file names, and this will ensure only valid requests are counted, so that valid requests are counted. Then we will check for how many times each file name appears, was requested, I can say. Then most requested file names will have the highest count. So this is what we can see, like the number of counts we have. The highest count is this one. So here it is counting in top 10 file names, so that we can get how many times this file name have been requested. And as it is stored in a list format, so it will extract from list. And coming to the last question, that is, we have to check for HTTP response code distribution. So for that, we will check for number of counts for each unique value in status. So for status distribution, we have the status column. For that, we will count the number of values and sort their indexes. So what it is basically doing, like, filter out rows where the status code is missing. We can check for any, which I've already done. So it will only check for the valid responses basically. Then we have used a function called as dot value underscore counts, which is like which counts how many times each HTTP request response code appears. So it will store the data values where HTTP response code appears, like for example 200, 404, 500. So it counts how many times the HTTP response code appears. Then we have used sort underscore index. Though basically it sorts responses codes numerically for cleaner output. 200, 301, I can say, or 404. Then we can convert it to dictionary. We have converted it to dictionary dictionary format. Then we will get the results: 200, 567,013. This is how we are getting it, is giving the count. This is the status, and this is the count of how many times each HTTP response code appears. So that's all about the assessment. Thank you.